Okay, on to the questions. Okay, number one, we have a chart here, shows the number of rooms per apartment. So we have 2 rooms, 3 rooms, 4, 5, or 6. They're not necessarily bedrooms, but just rooms in general. Okay, and we have the percent of apartments that have these number of rooms. Okay, number 1A, identify the random variable. Okay, so what's the variable that is changing? In this case, it is the number of rooms in an apartment. Okay, that's A. B, construct a probability histogram. Okay, so anytime you see probability histogram, they want you to create a graph. Okay, a histogram. Okay, we haven't touched on this, but there's histograms and bar graphs. Okay, they look very similar, but they have one thing that is different. So a bar graph, which we're actually going to touch on a different chapter. So a bar graph has bars that are spaced out, but a histogram looks like a bar graph, except the bars are attached. Okay, so whenever we're asking for histogram, we're looking to create one of these. Okay, so first, let me get this is difficult to do. I'm just going to put the phone down and create a chart, so graph. Okay, just drawing it here. Okay, so we're going to have, remember the first column is always your x-axis, your second column is always your y-axis. Okay, so we're going to have 2 rooms, 3 rooms, 4 rooms, 5, and 6 rooms. And then on their y-axis, we're going to have percentage. So 10%, 20, 30, 40, and 50. Okay, so we have, first one is 2 rooms at 15%. So 2 rooms at 15%. Okay, then we have 3 rooms at 30%. 4 rooms at 42%. 5 rooms at 10%. And lastly, 6 rooms at 3%. Okay, so number of rooms and our probability. Okay, so that's probability histogram. Okay, C, explain the meaning of the individual bars. This is the percent for each apartment type. Okay, so it's just the percent of each apartment type. Okay, describe the distribution. So I'm not gonna write it out, I'll just say it out loud. So I would say it starts at 2 rooms per apartment, and then it increases in probability up to 4 rooms. Okay, and then after 4 rooms, it decreases quite rapidly till 6 rooms. Okay, don't worry too much about that one. Okay, moving on to number 2. Okay, so a spinner has 2 equal sections colored red and blue. Okay, make a tree diagram and show the probability distribution for the number of times the spinner lands on blue when it's spun 4 times. So just a reminder what a spinner is. Okay, it's just a circle. And, oops, that's a terrible circle. And it has a little spinner. And you spin it, and it's going to either land on, in this case, red or blue. Okay, on to the next slide. Okay, so let's make a tree diagram. So we have to spin it 4 times. So remember, tree diagram starts at a point. Then after a first spin, we could either have a blue or a red. Okay, then that's our first spin. Then we have our second spin. So if we do blue on our first, we could then have a blue again or a red. If we land on red, we could have blue or red as well. Okay, that's spin number 2. And then we'll continue breaking each one into 2 points, into blue and red. And one more time for our 4th spin. Okay, so that's our tree diagram there. So the first part of the question says make a tree diagram, and the second part of the question says show the probability distribution. So now here's another key word here, 2 words actually. So probability distribution. Okay, whenever you see the probability distribution, they want you to make a chart. Okay, this is going to happen through the next 5 sections. We're going to make a chart. Okay, this one will be a little bit different than the other ones, but it's going to be the outcome and then the probability. So first, we're going to have, what are the outcomes that we could have when we do the spinner? So outcome represents X. Okay, this one I'm going to do a frequency just because we have a tree diagram. So we're going to do a frequency here. So how many times that outcome occurs. And then lastly, we're going to have a 3rd column, which is probability. Which is P of X. Okay, so if we spin a spinner, it has options of landing on blue or red. Okay, if we look at our probability or our tree diagram, we could have blue. We could land on blue 4 times. We can land on blue 3 times. Whereas one here, we could land blue twice. We could land on blue once. Or if we look at the very last branch, we could land on blue 0 times. So our outcomes, when we spin the spinner 4 times, and the question says for blue, we could have 0 blues. We could have 1 blue, 2 blues, 3, or 4. So those are different outcomes. Okay, and now we just want to do, well, how many times will it occur 0 blues, 1 blue, 2, 3, or 4? Okay, so I'm just going to label them here. So this spin is 4. If I do this branch, we have 3 blues. This branch is 3. This branch is 2. Then 3, 2, 2, 1, 3, 2, 2, 1, 2, 1, 1, and 0. Okay, so our frequency, so we have 1 outcome. 0 could happen once. For 1 time, 1, 2, 3, 4. Blue could come up once 4 different ways. For 2, it's 6. For 3, it's 4. And for blue to come up all 4 times. That will happen once out of the 16 total. Okay, so now our probability, which is your outcomes, your frequency divided by how many outcomes you have. So our probability for it to happen to land 0 times is 1 out of the total, which is 16. So 1 out of 16, 4 out of 16, 6 out of 16, 4 out of 16, and 1 out of 16. Okay, remember probability, you could write as 3 different ways. You could write it as a fraction, decimal, or percentage. Okay, I have them as fraction here, but you would like, if you leave it as a fraction, to reduce them. So we have 1 over 4 for this one, and this one would be 3 over 8, and 1 over 4. Okay, B, calculate the weighted mean for the number of times the spinner lands on blue. So going back to the first sheet, weighted mean is the outcomes times its frequency plus the next outcome times its frequency. Okay, so our outcomes are 0, 1, 2, 3, 4, and then our frequencies are 1, 4, 6, 4, and 1. Okay, so our weighted mean equals the first outcome, which is 0, times by its frequency, which is 1, plus the second outcome, which is 1, times by the frequency, which is 4. Okay, then we're going to continue. We have 2 times 6 plus 3 times 4 plus 4 times 1. All over the total number of frequency, which is 16. Okay, so we get 0 plus 4 plus 12 plus 12 plus 4 all over 16, which is 32 over 16, which equals 2. Okay, so our weighted mean, so our average should be 2. Okay. Okay, next, calculate the expectation for the number of times the spinner lands on blue. Okay, this is kind of obvious. So if you were to spin the spinner 4 times, how many times should you expect it to come up blue? Okay, so if I spin it 4 times, half the spinner is red, half is blue, so I'd expect 2 times. So we're just going to prove that with the expectation formula. Okay, so just reminder, expectation formula is this one here. So we're going from the first term to the last term. So we're taking each outcome and multiplying it by their probability. It's very similar to what we did with the weighted mean, which is the outcome times its frequency. This one, we're doing the outcome times the probability. And remember, this symbol here, sigma, represents adding. Okay, so our first outcome, which was 0, okay, times its probability, which is 1 over 16, right? So 0 and 1 over 16, plus next outcome, which was 1, and our probability was 4 over 16. Okay, I'm going to continue that. 2 times 6 over 16 plus 3 times 4 over 16, and lastly 4 times 1 over 16. Okay, as you will notice, I didn't use the reduced fractions. I just kept them as the original fractions, and the reason for that is it's easier to add them at the end. You'll see here. So 0 plus, remember when we're multiplying the numerators together, the whole number. So 1 times 4, 2 times 6, 3 times 4. So we have Let's get 4 over 16 plus 12 over 16 plus 12 over 16 plus 4 over 16. And that gives you 4, 16, and 16 is 32. Once again, divided by 16, which gives you 2. So this is proof that we should expect 2 blues when we spin the spinner 4 times. Okay, I'm just going to pause this video because it's getting long, and I'll just do the last one in the next video.